So this removal of vertex and edges increases the number of components of a graph. V1 and V5. There is no vertex is repeated in path. Every node exactly once you have to repeat because traverse a graph. Traversing means visiting each and every node exactly once. Starting vertex and ending vertex are same means it is a closed tree. Hello everyone, welcome back to my new session. I am Shweta, Computer Science faculty, Vidhyaashram First Grade College, MYSURU. In my previous session, I have discussed the types of graphs. So today I will explain about removal of vertex and an edge. Removal of vertex and an edge. So what is this vertex? The vertex is also known as node. Vertex is also known as node. The node or vertex of a graph is one of the objects that connects together. The vertex is also known as node of a graph is one of the object that is connected together. So example, we have V1, V2, V3, V4. So here we have four vertex, right? V1, V2, V3, V4. This vertex or node of a graph is a object that connects together. Clear? So now removal of vertex and an edge. So let G of VE be a graph removing a vertex, that is V belongs to V. From G we obtain a graph denoted by G minus V because we are removing one vertex or one or more vertex in a given graph. Clear? So G minus V. Similarly, removing an edge, that is E belongs to E, results a graph denoted by G minus E. So removing of vertex is G minus V and removal of an edge is G minus E. So edge is E1, E2, E3, E4, right? So here we have four edges and four vertices. So here we are trying to removing the vertex and the edges, right? So G minus V and G minus E. And removal of vertex or edges increases a number of components of a graph. So this removal of vertex and edges increases the number of components of a graph. So now, first one is cut vertex. So removal of vertex means we are cutting one vertex in a given graph. A cut vertex of a graph is a vertex such that the removal of the vertex makes the graph disconnected. So example, if you have a graph, if you are removing a vertex means the graph is disconnected, right? Example, V1, V2, V3 and V4. So here I have one graph, right? So this is V5. So now I'll show you how to remove the vertex. We have V1, V2 and V3. So now here we have V5. So now I have removed this V4 vertex V4. So it's disconnected, right? So I have removed here V4 I have removed. So the graph is disconnected. So this is called as cut vertex. Cut vertex. It is very simple concept, very important concept. It is 2 marks question. So what is cut vertex or what is cut edge? So here I have removed vertex 4. So it's become disconnected graph. Clear? This is an example for cut vertex. Or else you can remove this V. And this is V5, right? So if you want, you can remove this V5 also. So if you are removing, it will become disconnected graph. So here we have V1, V2, V3, V4 and V5. So in this example, have removed V4. So here have removed this V5. So this is an example for cut vertex. So you can give any other examples. Clear? So next one is cut edge. Cut edge is also known as bridge. If you are removing the bridge, what will happen? So like that, if you are removing the edge, the graph will be disconnected. A bridge is a single edge whose removal disconnects a graph. Again, here also the cut edge removal disconnects a graph. Clear? Example for cut edge: V1, V2, V3, V4 and V5, V6 and V7. Clear? So here we have 7 vertices: V1, V2, V3, V4, V5, V6 and V7. So now E1 edge and E2, E3, E4, E5, E6 and E7 and E8. Here we have 8 edges, E1 to E8. So now I'll remove one edge. If you want, you can remove many edges. So now I'll remove this edge. So it will become the disconnected graph. So which edge I have removed? I have removed this E5, edge E5. So it will become V1, V2, V3, V4, V5, V6, V7. So I have removed this E5 edge, right? So it is E1, E2, E3, E4. I have removed E5 and it is E6, E7 and E8. I have removed E5. So this I have removed. So this is an example for cut edge. So now you can remove this edge also, or else you can remove this E6, E7 or E8 or E4, etc. So it will become a disconnect graph. So removal of cut vertex and cut edge. This is very important question. So you can expect this question for 2 marks. What is cut edge and cut vertex? It is last year question paper question. So please practice this example. And next one, we have connected and disconnected graph. So in previous example only I have told you about disconnected graph, right? So what is connected and disconnected? A graph G is connected if there is a path between every pair of vertex. So path between every pair of vertex means there is no disconnection between the vertex, right? That is called as connected graph. Example for connected graph. Here V1, V2, V3, V4, we have 4 vertices and 4 edges. Graph G is connected if there is a path between every pair of vertex. There is a path between every pair of vertex is called as connected graph, and from every vertex to any other vertex there should be some path to traverse. So there is a path between every pair of vertex. There should be path to traverse. To traverse from one vertex to another vertex, there should be a path between every pair of vertex. That is called as connected graph. And next is disconnected graph. There should not be a path between every pair of vertex is called as disconnected graph. Example for disconnected graph, V1 and V2. There should not be a path between every pair of vertex is called as disconnected graph. Clear? This is connected graph and this is disconnected graph. So you can write this also. There is no path between every pair of vertex, that is called as disconnected graph. So you can write this example for connected and disconnected graph. And the next one we have path. So what is this path? So in previous diagram I have told you about path. There should be some path to traverse. So path means there should be a path from V1 to V4 and there should be a path from V4 to V3 and there will be a path from V3 to V2. So this is called as path. To traverse from each and every vertex there should be a path, right? So here if no vertex is repeated, in path, no vertex is repeated. Example for path. Here V1, V2, V3, V4 and V5. no vertex is repeated is called as path. There should be a path between every pair of vertex. Here V1 and V5 are path because no vertex is repeated. So here it started V1 and its end with V5. Here no vertex is repeated, then it is called as path. V1 and V5. There is no vertex is repeated in path. This is an example for path. So otherwise you can give this. This is also path because here no vertex is repeated. Clear? So next one we have cycle. So what is this cycle? So it's not a normal cycle. Cycle is a closed path. Cycle is a closed path. So here in path there is no vertex is repeated, but in cycle the vertex is repeated and it is a closed path is called as cycle. That's it. Example for cycle. Here is a closed path. Closed path is called as a cycle. Clear? It's a complete graph. And next one is walk. So what is this cycle walk? So it is a part of graph theory. Clear? So walk means a walk is a sequence of vertices and edges of a graph. That is, if we traverse a graph, then we get a walk. So what is this traverse? So traversing means visiting each and every node exactly once. Traversing means visiting each and every node exactly once. So here, traverse a graph, then we get a walk. If you are traversing a graph, you will get walk. So now, vertex can be repeated in walk. Edges can be repeated in walk. Listen. So here I have one diagram. 1, 2, 3, 4 and 5. You just observe the colors. So here it is green color and it is black in color. So what is this walk? 1 to 2. If you are traversing from 1 to 2 and again 2 to 3, 3 to 4 and 4 to 2 and 1 to 3. So now it is a walk. Here you are traversing each and every node exactly once, right? So 1 to 2, 2 to 3, 3 to 4, 4 to 2 and 1 to 3. So every node you are visiting once. So now this is a walk. Clear? So walk means 1 to 2, 2 to 3, 3 to 4, 4 to 2 and 1 to 3. So again, if you are drawing this 3 to 5 and 5 to 4, it will be not a walk because here 3 to 5 is not a walk because already have visited from 3 to 4. If you are repeating again from 3 to 5, it will be not a walk because every node exactly once you have to repeat because traverse a graph. Traversing means visiting each and every node exactly once. This is called as walk. So 1 to 2, 2 to 3, 3 to 4, 4 to 2, 1 to 3. But if you are repeating 3 to 5, it will be not a walk. So this is called as walk. So this diagram, you can write it for walk. Clear? So next one we have types of walk. In walk, we have two types, that is open walk and closed walk. So what is this open walk and closed walk? Walk is said to be an open walk if the starting and ending vertices are different. Starting and ending vertices are different. That is, the origin vertex and the terminal vertex are different. That means starting point and terminal point should be different. That is called as open walk. And what is this closed walk? Walk is said to be a closed walk if the starting point, that means starting point and ending point should be identical. Identical means same. Then we can consider as it is a closed path. starting point and ending point should be same, then we can consider as it is a closed path. If a walk starts and ends at the same vertex, example, a walk starts from A and B, C and A. Here you just observe this diagram, 1 to 2 and 2 to 3, 3 to 4, 4 to 5, 5 to 3. So this is an open walk because the starting point and ending vertices are different. I'll repeat, the starting point is 1 and the ending point is 3. 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 3. So ending point is 3, starting point is 1. So it is called as open walk. Clear? So starting point is different, ending point is different, means it is an open walk. So 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 3 is a open walk. So here walk means visiting each and every node exactly once, traverse once, and the starting point and ending point vertex should be different. This is an example for open walk. So next is closed walk. You just observe this, 1 to 2, starting point is 1, 1 to 2 and 2 to 3, 3 to 4 and 4 to 5, 5 to 3 and 3 to 1. It is very simple. Understand the logic. Starting point and ending point are different, means it is a open walk. Starting point and ending point is same, means it is a closed path. 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 3, 3 to 1. So again we reach the same starting point called 1, vertex 1. So this is an example for closed walk. Closed walk and open walk. Clear? But you have to mention this in exam. Clear? Open walk and closed walk. So this is an example for open walk and closed walk. Starting point and ending point is different, means it is open walk. Starting point and ending vertex is same, means it is a closed walk. That's it. And the next concept is trail. So what is this trail in graph theory? Trail is an open walk. So what is open walk? Open walk means starting vertex and ending vertex should be different. Clear? Starting point and ending point should be different, means it is an open walk. Trail is an open walk in which no edge is repeated but vertex can be repeated. No edge is repeated, vertex can be repeated. I'll explain with an example. So here you just observe this diagram. Starting point is 1, 1 to 3, 3 to 8, 8 to 6, 6 to 3 and 3 to 1. So again I am repeating the vertex 3. 3 to 2. 3 to 8 has done. Here I have repeated this vertex 3. Vertex can repeat but edges cannot be repeated in trail. Trail is an open walk, so starting point and ending point should be different and vertex can be repeated, edges cannot be repeated in trail. I'll repeat. Starting point is 1, 1 to 3, 3 to 8, 8 to 6, 6 to 3 and 3 to 2. So this is an example for open walk, right? So trail is an open walk in which no edge is repeated, vertex can be repeated. So what about this closed trail? So 1 to 3, 3 to 8, 8 to 6, 6 to 3, 3 to 2 and 2 to 1. So this is closed walk. Closed walk because starting point and ending point are same. Starting vertex and ending vertex are same, means it is a closed trail. So second example is for closed trail and this is for open trail. So very easiest examples I am explaining. Please make a note of it. So easily you can score in graph theory. So in every concept you will learn something in graph theory. So it is a trail. Trail means it's an open walk and vertex can be repeated, edges cannot be repeated. And next one is circuit. So what is this circuit? Circuit is in physics, right? So why we have to study this circuit in graph theory? So let us understand about circuit. Traversing a graph. Traversing means visiting each and every node exactly once. Traversing a graph such that not edge is repeated. So edges cannot be repeated. If you are using this edges 2 to 4, again you should not use this 4 to 2. That is called as edges cannot be repeated. But you can use this vertex 2 for 2 to 1 and 2 to 4. But vertex can be repeated, edges cannot be repeated. Then it should be a closed trail. Closed trail means it's a circuit. Clear? So you can observe this diagram here. Vertex can be repeated, edge not repeated, right? So now, how to form a circuit? You just observe this. Starting point is 1. So in closed trail, starting point and ending vertex should be same. Then only we can say it is a closed trail. So 1 to 2 and 2 to 4 and 4 to 3, 3 to 6, 6 to 8, 8 to 3. So here I have not repeated the edges, but you can repeat the vertex. And again 3 to 1. So we have reached the same starting point. I'll repeat 1 to 2, 2 to 4, 4 to 3, 3 to 6, 6 to 8, 8 to 3, 3 to 1. Have used this twice, right? Have repeated this twice because 4 to 3, again 3 to 6, 6 to 8, 8 to 3, 3 to 1. So this is a circuit. Clear? Starting point and ending point should be same in circuit. Clear? So it should be a closed trail. If it is trail means it should be a open walk, and if it is circuit means it should be a closed walk. That is the difference between trail and circuit. It is very simple concept, and here circuit is a closed trail. So circuits can have repeated vertices only. So repeated vertices we can use, but we can't use the repeated edges in trail and circuit. Clear? So trail is an open walk, circuit is a closed walk. This is an example for circuit. So starting point and ending point should be same in circuit, but it should be a closed walk. So no edges can be repeated, but vertex can be repeated in circuit. So today you learned the concept of path, cycle, cut vertex and cut edge, and have explained circuit, open walk, closed walk and trail. It is very important question for 2 marks. Sometimes you can expect this for 4 marks also. So please practice all the diagrams so easily you can score in graph theory also. In my next session, I will come with a new concept. Thank you.